cool. So our next speaker is Josh Dolitsky. Josh, you may know as the author and creator of Chart Museum, which is the largest open source Helm chart repository. He's one of our senior engineers at Codefresh, and the person that I Slack every time I break something with Helm. So with that, come tell us about Helm 3.
All right, so nice to meet all of you. I'm Josh Dolitsky. I live in Chicago, work for Codefresh, creator of Chart Museum, which is kind of how I got involved with the Helm team and the Helm community. And I'm going to talk about Helm is coming up with a new version, Helm 3, that has a bunch of new changes. I'm going to talk about what we can expect if we're using Helm 2 today, what we're going to change migrating to Helm 3. So before I go into that, so Eric talked a lot about what Helm does. The Helm project started at the end of 2015. Deus had a hackathon, and they developed something called Kate's Place. That was basically a way to.
Are you sharing the slides? Sorry. Which is also, by the way.
Thank you. I would have gone the whole.
You made all these nice slides.
I know. I spent a lot of time. Okay, so I won't tell. All right, so that's me. So a little bit about where Helm came from. It started at a hackathon at Deus, and they made something called Kate's Place, which was a simple way to deploy apps into Kubernetes. And they announced it later that year at the first KubeCon. From there, they worked with the team at Google that was building something called Deployment Manager. And Deployment Manager is essentially, from what I understand about the history, what Tiller is today, the server-side component. And fast forward a little bit, end of 2016, Helm 2.0 is released, which is a combination of what Helm v1 and Deployment Manager was and what Helm as we know it today. I don't have an item for 2017, but 2017 was a big year of growth for Helm. You see a lot of companies and enterprises using Helm to deploy applications to Kubernetes in production. And then recently, Helm has joined the Cloud Native Computing Foundation, which is a really big deal because this is kind of a vote of confidence that Helm is the tool to manage your applications in Kubernetes. And it also allows us to kind of, we were operating under the Kubernetes organization. So now we're able to come up with our own governance model and move more quickly than had we stayed with Kubernetes. So there's a lot of different things going on with Helm 3. I kind of see three major things that you should prepare for. And the first thing is that Helm is going to ship with an embedded Lua engine. Lua is a programming language, kind of similar to JavaScript. That's going to basically make charts more robust and extensible. The next is the removal of Tiller. So a big complaint, I was talking to someone actually earlier, the reason they don't use Helm is because of Tiller. And Tiller is basically the server-side component. So the client, Helm CLI talks to Tiller. Tiller makes sure that the resources are provisioned on Kubernetes. So they're going to basically figure a way to do this without the server-side component. And then the third, which I'm actually very involved in, is some changes to the way that we work with chart repositories. And this has to do with putting access controls on who can install, who can upload charts to a repository, things like that. So the first thing, embedded Lua. One thing to note is that they're going to introduce this embedded Lua, but it's not going to replace Helm as we know it today. So charts that are in the community repo that you rely on today, you could still use with Helm 3, no problem. Lua is going to be kind of a way to extend the way that you write charts. So you can use it with the templates or completely in place of the templates. With this, you're basically going to treat Kubernetes resources as objects instead of strings. So if anyone has familiarity with the module troposphere to CloudFormation, it's the same idea where you're basically using a programming language to create a text file or a YAML file in this case that defines your infrastructure. There's going to be a new event system. So right now you have kind of hooks that you can do certain things after the install or after the deletion of the release. With the Lua system, we're going to have access to every stage of the installation. So let's say right before we get our chart dependencies, right after we get our chart dependencies, right after we template the templates into Kubernetes YAML, right after we install. At every stage in that life cycle, you can modify the chart. So for example, let's say you pull in a dependency on the WordPress chart and it's using MySQL by default, you can pull it in, pump in Postgres, something like that, and still use that stable chart without having to fork it and re-release it on your own. The Lua engine is going to be sandbox, so that means it's not going to create kind of like a new security concern because it's going to actually limit what you can do. It's going to be a DSL, and that's the reason that Lua was chosen by the core team, is that it's almost designed, the language itself is almost designed to limit which pieces of the language are able to be used. With that, you're going to be able to, and this is kind of like Eric's monochart idea, but basically you're going to have these library charts that are just Lua scripts that basically say, give me a stateless web service. And these will be community developed and you can import them and maybe just pass in your Docker image, number of replicas, something like that. And then plugins. So Helm plugins exist today pretty much as shell scripts, or you can develop them as a Go binary and figure out which runtime you're on and install them. Because Lua is baked into the CLI, you don't need to rely on, for example, if your plugin's written in Python, the runtime needs to have Python. Your environment needs to have the Python runtime. If you write your plugin in Lua, it will run on Windows, Mac, Linux, wherever you're running it. So here's an example of a template for a pod in Helm today. So all these, for the people who aren't familiar with Helm, the curly braces is basically Go templating that plugs different values into the Kubernetes resource and then ends up static in the end. With Helm 3, you have the option to use Lua and actually define this as an object. So you can see you have this release service or Helm. It's kind of more programmatic way and you can see the pod is defined as a variable. But this isn't this is actually more code than the first version, right? It might be more manageable in the long term, but it's still bigger. And the way that we can kind of alleviate that is through these library charts. So imagine if you had a library that's called mylib.pods. This is how you create a pod, and then you're basically just passing in Alpine 3.7 and restart policy always, and you're adding that to the application. So the next thing is the removal of tiller. So the removal of tiller is basically shrinking the security model for Helm, because right now it's a client-side CLI and a server-side server that basically manages where to create resources. So you're basically now, because that's gone, you're leaving the authentication and authorization up to Kubernetes itself. So you're going to talk directly to the Kube API. If your user is allowed to create a pod in namespace X, you can do it. If not, you can't. Right now, a lot of people are basically tying tiller to the cluster administrator. So it's running in like God mode. So this is basically removing a lot of concern that people have with Helm, in that it has its own model for security. And tiller was also doing things such as preventing race conditions. So if multiple developers are trying to upgrade at once, it would manage, oh, this developer's changes version 2, this developer's changes version 3. So to mitigate that, instead of using 1, 2, 3, they're going to introduce ULIDs, which is kind of a way to say this is the timestamp plus the machine plus XYZ. That will help alleviate any type of race condition, because it's all client side only.
Quick question. So it works regardless if you use Luau or the existing.
Correct.
structure, right?
Correct. Yeah.
Repeat that question for the video stream.
Yeah. So the question was, it works regardless if it's Lua or templates, and the answer is yes. It doesn't exist yet. So.
Yeah.
So now, now that the state of Kubernetes, we have CRDs are fully supported. So instead of tiller storing all these different releases and config maps, they're going to be stored in a custom resource that's defined by Helm. And there's 2 of them that are going to be introduced. Release, which basically is the name of your application and the software that it's deploying, plus release versions, which there will be many release versions per release, where this is basically your 1, 2, 3 history of your release. So really quick, this is a diagram of kind of how Helm 2 works today. You open up a tunnel to tiller, communicate to it via gRPC. Tiller then talks to the Kubernetes API to actually create resources, as well as Helm releases, which are now stored as config maps. So basically, anything that any command that you're running against tiller is up to the service account or whatever that tiller is running in. So for people that are concerned about security, the way that this has been solved is running a tiller per namespace, which is kind of, now you have a bunch of different things running all over your cluster. In Helm 3, tiller is going away. So Helm will communicate to the Kubernetes API just like everything else over HTTP. Your user has the access to create resources based on your role. that has been defined for you. And then the releases are stored in these new CRDs, release and release version.
What's the idea of the upgrade path?
What's that?
What would the upgrade path look for the?
That I don't know. I do not know.
Don't repeat the question.
Oh, the question was, what's the upgrade path from Helm 2 to Helm 3? I assume there will be some nice scripts when that time comes. So the third thing is changes to the chart repository subsystem, and this is an area that I'm involved with because it relates to Chart Museum. So the idea is that we have commands to, like Helm fetch, to download a chart. We don't have commands to upload a chart. And part of that reason is there's really no opinionated way to spin up a chart repository. You could put it, any HTTP serving thing can be a chart repository, S3, GitHub, pages, etc. So Chart Museum has an HTTP API for uploading your chart to a repository. So the conversations that are going on is that the API specification that Chart Museum uses will essentially become a spec, and any server that adheres to the spec for uploads can accept an upload via a Helm push command. Similar to the way that downloads work today, plugins can actually specify a different protocol. For example, S3, there's a Helm S3 plugin that'll let you push to an S3 repository, or create a chart repo from an S3 repository. You can have a plugin that changes the way that the upload occurs, but the default will be some spec based on the Chart Museum API. And then lastly, there will probably be a Helm login command that allows you to authenticate against a repository, and an entire OAuth 2 flow that kind of basically takes that token and determines whether or not your user is allowed to push this specific chart or download this specific chart, things like that. So here's kind of what a basic flow looks like today. You would add a repository pointing to some site that's hosting your index YAML, and the best thing we have for authentication now is basic auth. So you could pass a username password combination. You would then package your chart when you're ready to upload it to the repo. You would run some script, something to upload that chart to your repository. Update the repo. This is later on. Update the repo, and then install the chart. In Helm 3, we'll likely have a Helm login command, semantics of which is being discussed. But imagine if you have Helm login mysite.com, the identity provider for that is GitHub. That might open a browser that has a GitHub login to that application. You log into that application. The CLI then gets a token that it stores locally. You add some repo that's tied to that site, and from there you can do push and install without re-authenticating, and that authorization flow will be handled for you. The token will be refreshed like via some specified authentication flow. Some other things that are kind of interesting that aren't related to those other three topics. Right now, so there's hooks. So you can have like a post install hook that maybe adds a pod to the deployment. When you delete your release, that pod will remain unless you do kind of some hackery. So you have the ability to basically mark hooks as managed, and any resources that creates, Helm will then tear down, things like that.
You know, they're like planning fully cascading deletes, or is there any changes coming to that?
So the question was, are they planning any cascading deletes? What do you mean by that?
Like for now, I think right now, Helm, for example, can create cron jobs. You can delete cron jobs, but the jobs are not getting deleted because they're in the work.
Yeah, so I think that's kind of what this covers, is that basically it'll track any resources that are created. And I think that will kind of be enabled by the Lua piece. I'm not exactly sure. Another thing is, so this index YAML that defines the repository, that's now going to be JSON simply because of performance. If you have a really large repo, there was a talk at this Helm Summit that basically showed how the in-memory size was really large. So by moving it to JSON and partitioning it, where basically that index file will not have all your chart versions, it'll just have the names of your charts. And then if you want to go install, let's say WordPress, that'll have its own JSON file. So just kind of a small change to that behind the scenes. Schematized values. So this is something that a lot of people have issues with too. You can basically pass arbitrary values to a chart and just hope that it works. You can put a file now in your chart called value schema YAML that will contain this, this value needs to be there, it's required, it needs to be an integer, things like that. And then the Helm serve command, which will start a local server, will be removed. Chart Museum is now a child project of Helm. So if you want to host a repo, that's there for you. Helm reset, which was to remove Tiller, will also be removed because Tiller is removed. And then this last bullet is kind of like it's up in the air. So if you have any kind of things you need to see in Helm, it's an open source project, so it's kind of still being defined, and you have the opportunity to go and make those proposals right now. If you want to know more, I was talking about the proposals. GitHub/Helm/community contains everything about the Helm community. There's a Helm v3 directory there that contains the initial proposal. Look at the pull request. I have an open pull request that I need to get back to. But basically, you can make requests against that proposal and get your changes that you want to see into Helm 3. And then Matt Butcher, who's on the Helm core team and one of the initial creators of Helm, put together a blog post that I'm kind of basing a lot of this information on. And Codefresh, I've cleared this with the marketing team. This is our new company slogan. We're the platform, we're the platform committed to supporting Helm 3 on day one. So we're heavily kind of like on board with Helm and kind of trying to stay on top of the latest and greatest. So you can expect that Codefresh will support these types of things the day that Helm 3 is released. Thanks. Thank you. Questions?
So about how far in the future do you expect day one to be?
I can't comment on that.
So I'm clear with marketing. I have a question. Given Lua support, was there any talks about having like a persistent runtime or kind of like a Tiller is gone, but maybe there's like another server inside that will basically be the state, retain the state.
So the question was, with Tiller gone, will there be another component to maintain the state? And I think the answer is no, at least on the server side. So the client should know how to talk to those CRDs, and that should be the only thing that exists in the cluster.
I mean, in essence, the CRDs are the thing maintaining the state, right?
Right. Yeah.
Right.
So in line with that question, you mentioned something you called ULITs. There's supposed to be ways now in Helm 3 to be able to break race conditions, but dev machines can have timestamps that are not synchronized. So how does that really work?
Yeah. So the question was, Tiller was preventing race conditions, and with the introduction of ULIDs, it's supposed to fix that. But your dev machine could have some old date that could. Yeah, I don't know. I'm sure that'll be one of the first issues. But good point.
I would think that purely speculating that it might actually pull it from the server when it's going, right? So it's using one time to build off of, but that's speculation.
There's a server component to this still somewhere.
No, because it's just talking to the Kubernetes API, right? So it doesn't necessarily have to have a like a tiller running. It's just asking Kubernetes what time it is. That would be a guess. Again, don't know either.
Yeah, it's all very like early stage. So, yeah.
We'll stay tuned.
Yeah. All right.
Cool. Well, thanks,
Thank you.
Josh.